First and foremost, thank you for being here. I appreciate you guys hanging by and waiting as we set up to kick off the presentation. It is a distinct honor to have you here today to learn about the integration of Google BigQuery machine learning in Tableau. So we're going to kick it off. My name is Edwin DeLeon, and I work for Tableau within the professional services group. It's a group that specializes on delivering great dashboards, great data strategy, great solutions on-site or remotely for clients. I've been doing that for about 2.5 years. Before that, I was a TA at CREF, where I was analyzing financial and markets data. And before that, I worked on my master's in chemical engineering to be able to optimize the production of syngas for a Fischer-Tropsch reactor. So without further ado, let me introduce you to my colleague, Monica Wilbrand.
Hey, good afternoon, guys. Thanks for being here. Monica Wilbrand, also from professional services at Tableau. I've been with the organization for about 5 years. My background spans working in semiconductor engineering before joining the services group, and I can be found working across multiple verticals across the country in public and private sector. I'm happy to be here today with my colleague Edwin to give you guys a presentation on GBQ-ML in Tableau.
So our goal here today is to demystify what we mean by machine learning. We're going to be covering 2 model types out of the full model types you can actually use today with BQML. Those would be linear and logistic regression. And I say demystify because often it's a term, you hear the word machine learning and you say to yourself, what is it, right? So we want to use a metaphor that goes very close to home for, I think, perhaps both of us, and that is snowboarding. It's the kind of sport that we don't necessarily practice every day, but when we did learn it, we learned the fundamentals. And as we go back and practice it again, we bring those fundamentals with us as we embrace the risk involved with snowboarding, right? As you're getting off the lift or the gondola, you have to make sure you're going off the ride and you're not going to fall, all right? That's step number 1. Step number 2 is to start kicking off into the slopes and then start playing with the deceleration and the acceleration of your snowboard so you don't fall as often as you would when you're an amateur like myself. So we're going to be presenting a framework or what we call a blueprint so that you can go home and say to yourself, okay, I understand the syntax involved with GBQML, and I understand the ease and the facility that comes with integrating it in Tableau through custom SQL. And of course, we're going to be covering a few examples of how you can use Tableau's parameters to kind of bring out dynamic visualizations.
Great, so with that, can you tell us a little bit about what BigQuery is or why we would use it?
All right, so BigQuery allows you to store massive amounts of data on the cloud. BQ calls them data sets, and within data sets, you can load tables. If that isn't already on the cloud, and you can streamline that to BQ, you can actually go and load a flat file, a JSON connection, or a number of different data types to BQ. And why would you want to be concerned with using BQ? Well, as you know, today you have a lot of cloud warehouses, but you don't have the machine learning engine. So BQML or BQ integrates the machine learning component so you can take ML directly where your data resides. Let's see a show of hands here and understand exactly how many of you today use SQL to connect and prep your data before you visualize your insights. Many of you. So BQML makes that easy because the syntax is SQL-esque, is almost entirely SQL. You can get as fancy as you'd like or as simple and as standard as you'd like with a select star from query. And we're going to go through all the different SQL-like commands that will help you prep your data, will help you predict your build your model, evaluate your model, and subsequently predict it to get that into Tableau. So Monica, tell us about what we're going to be talking about today in depth and other options available to the public.
Yeah, I'd love to. Thanks, Edwin. OK, so as Edwin noted, there are a few different types of modeling that we can do using Google BigQuery with machine learning. The ones we're going to focus on today are linear regression, which Edwin will walk through that example, and logistic regression, binary logistic regression, which I'll walk through a use case of that as well. There are a couple of other models available, which we've noted, the k-means clustering and TensorFlow beta. So with that, we'll move on to a dashboard. And Edwin, can you tell us what we're looking at here?
Yeah, so this is a snapshot of what we're going to be analyzing from a prescriptive and descriptive way before we take the leap to be predictive. Right? So Tableau already facilitates that today. We're going to be looking at a macroeconomic data set or macroeconomic data table. It's very, very simple to keep things fundamental. Fun, you can't have fundamental without fun, right? Here we begin to study the relationship between unemployment rate and GDP growth, right? So there's a thing called Oken's law that stipulates that for every 1% decrease in unemployment rate, there's an expected 2% increase in GDP growth, real GDP growth, right? So we're going to put that to test and kind of understand that Tableau today gives us that linear regression capability, but when we want to train a data model with much larger historical data sets so that the linear regression model is perhaps more reliable, and we can streamline that directly to Tableau with our evaluation and test data, right? Instead of having to go and get the intercept and having to get the slope to get a column with a calculator field that actually outputs your test data. So it's a little less mechanical and more seamless.
So to clarify what we're looking at here on this dashboard, this is prediction using Tableau Desktop alone without GBQ, is that right?
No, this is essentially establishing, yes and no, right? So you're using a data set that stems from 2009 to 2019, and it says, all right, is there really a relationship between the two, right? And because the data set is so small, you get to see an R-squared value that's not where we expect it to be to prove that it's a reliable linear relationship between the two. So it, of course, informs us what we can use to train it on the cloud with a much larger data set, and then, of course, use a different test data set to build that prediction using BQML. That's the next slide. So as you see here, I was able to go to BEA, the Bureau of Economic Analysis, and BLS, the Bureau of Labor Statistics, to be able to get GDP data and unemployment rate data, respectively, for a wide period of time. And I use that information as my training data, right? And eventually, I was able to select the number of rows that I wanted to randomly use to train the ML linear regression model. And from there, I was able to load the data set again to see exactly how reliable those predictions were relative to the Fred data that essentially gives us real potential GDP kind of with forecasted projections or projections.
Right, so how might we connect to Google BigQuery using Tableau?
So I'm happy to continue to, I guess, rephrase that today you would be able to connect to BQ or Google BigQuery in all of our products in the Tableau platform, from Tableau Prep Builder to Tableau Server, Tableau Desktop, and Tableau Online, right? And so that's pretty ridiculously awesome, because you're not subjected to just doing that on desktop, or maybe you want to join it and prep it and integrate it and enrich your data in Tableau Prep Builder. So it gives you the flexibility, right? If you opted to, say, connect directly to your Tableau Server platform, to the cloud, or Tableau Online, to the GCP, the Google Cloud Platform, that's something that you can do today. So that excites us. And hopefully it excites you as well. So how many of you are familiar with what linear regression is all about? Sweet, awesome. Just a show of hands, how many data engineers or ETL developers do we have in the room? Sweet. How many data scientists do we have in the room? Everyone. All right, so I'm not going to have to explain to you guys what linear regression is all about, but when I was learning BQML, there were terms that were kind of foreign to me, right? Predictors, response outcomes, response or outcome variables. And in my head, I'm thinking to myself, oh, when I was in school, I learned it as independent variables and dependent variables. So I'm just kind of presenting the terms that may be synonymous to each other. And of course, what is it? Just establishing a relationship from a dependent variable or predictor to an independent variable, your response or outcome variable. So how may we proceed with a framework and share it with this fabulous audience today?
Yeah, let's talk about the steps that we're going to go through and the ML commands that we're going to use in SQL. So it's a very structured framework that we're going to look at. You're going to see this sort of flow diagram a number of times as we walk through with either the linear or logistic regression, because they're quite similar. And with the analogy of snowboarding, maybe it's going from one mountain to another. You're just applying the same skill set that you've learned with some slight tweaks to accommodate for whatever your environment is. So here, looking at our flow diagram, Edwin, can you walk us through what our steps are?
Yeah, it would be a pleasure to. So, when you're first learning a brand new model, it's likely that there's public data sets available on the cloud, like Google's public cloud data. So that's already loaded up there. You don't need to worry about uploading data that's, kind of speaks to you. But if perhaps you're getting data from, like I did, from BEA, BLS, Fred, and I may want to prep it a little bit, I may want to make sure each metric is what I think it is, I'm probably going to do that in a different platform or different software, and eventually I'm going to want to publish that or upload it to the GCP. So we're going to walk through what that's like as well, which is a very fundamental step. And once you've actually defined what are the labels, what are the features you're going to want to be connecting to, then you can jump to the next step, which is, all right, let's create our predictive model with training data.
Okay, so after we create our model, it looks like we're going to evaluate. Can you speak a little to the evaluation?
Yeah, so each of these steps comes with a BQ command, which is very, very simple to kind of follow. But you can also see it in the interface, right? If you choose to say to yourself, oh, wonderful, the platform already, everything that I have to evaluate the model, to evaluate the R-squared, the mean absolute error, and all of the other metrics related to my model type, I want to bring that and visualize that and integrate it into a visualized dashboard, into a report. Then I will, of course, run that SQLS command using the evaluate syntax.
Okay, and it looks like next we're going to predict, and here is the data that we're going to pull into Tableau. Is that right?
That's right. So as you choose exactly what training data, how much training data to feed to your prediction to continue to make your model more reliable and more trustworthy, then you can take the step and say, okay, let's predict it. When I first learned it, I wasn't necessarily looking at the valuation and saying, oh, no, that R-square won't let me move forward. I was kind of moving forward just so that I can understand the way to integrate the two platforms with each other. And as you know, when you have created your prediction, you will be able to also see the results in GCP, in BQ, but you could also bring those results into Tableau, and that's exactly what you're going to start to analyze when you establish that connection, authenticate to your account, and ultimately start visualizing and analyzing.
Okay, and then it looks like our final step will be opening it in Tableau. So just to recap these steps, what we're looking at is when we upload our data to the cloud, if it's not already hosted there, we're going to use this ML command. We're going to create or replace our model, which is where we're specifying if it's linear or logistic regression. We're going to perform an evaluation. So in this case, we're evaluating what we've put in our model, so we can specify what's in our training set. Are we using 10% or 90% of our records to create a prediction? Are we using a certain set of features, let's say, to build that model? We'll perform that evaluation and see the accuracy in Google BigQuery in the console. And we can determine then, if you wanted to do some feature engineering or query optimization, which we won't get into today, but you could do this evaluation and then decide to make those changes. We can then run the ML predict command, and then we'll have our column materialized in our data set, which we are going to connect to in Tableau. So let's kick it off with linear regression. Edwin?
So going back to the fundamentals, the first thing, once you've uploaded your data and understand where your data resides in the cloud, you're going to start creating your model. So we're jumping into step number 2, because in Monica's part of the presentation, she will cover the ingesting component. And I will cover it slightly as well. So you define where your model is, and immediately after defining what you want to name your model, all right, you need to allude to what is the data set that you're connecting to. Perhaps if you have multiple projects in BQ, you want to also append the project name dot dataset name dot model name, which is what you're about to determine. From there, you're of course going to specify whether you have linear regression or logistic regression, and you're going to specify what is the variable, what is the label that you're looking to predict. And as Monica specified, when you're creating your model, you need to determine exactly from a big query of information, from a big SQL query, you may want to randomly use the information to create a model. And of course, once you've specified those options, you just throw in as and then run your selected columns, your selected data elements, and specify exactly where it's coming from. So at the bottom, you're able to see if you have multiple project names, you specify what the project name is, the name of your data set, and the table that you're querying the information from. Let's go back to the previous slide for a sec. Something that we struggled with when we were first learning this was the use of the Grabbe or the accent mark whenever we are defining the model name or whenever we're querying information from a particular table or a particular view that we've built. It's a very subtle thing, but it can really trip you up because you're used to just throwing in the single quotation marks or the single apostrophe mark, but really it's the Grabbe that you want to use in between the model name and your table names. So I mentioned earlier we're going to be covering Oken's law. So when I was loading my data, I realized that my percent sons weren't coming through, and a bunch of different marks weren't actually uploaded the way I wanted them to. So in this case, it's really substituting the syntax that we saw on the previous slide with information. All right? So I wanted to name my data set Oken's Law Q because the information was presented quarterly, like GDP normally is presented. And And then, of course, you get to see how the variable or the label that I'm predicting is percent change of GDP, right? And from there, you're able to see that I'm keeping it simple. I'm using, I have to specify the variable that I want to predict and that predictor in my selected columns. And then I just say, oh, take it from this individual table. These two slides you see here will cover the syntax for evaluating your model. And I'm not going to dwell on this for too long because I'm going to show you what that's like in BQ in just a second. But as you can see, the select star really says, bring all the different elements, all the different columns that help me evaluate the model. And I'll show you what those are in a second. The next step is the one step that you're going to use to integrate into Tableau, right? Once you have built your model, evaluated your model, the next step is to create those predictions with test data and bring it into your dashboard, or your workbook, rather. So we're going to switch from the presentation to BQ. So really quickly, I'm going to find the project where we saved everything. And Monica was going to remind you to always make sure you select the right project to connect to. Otherwise, it could be a painful process. Right? Otherwise, you may have to always define what that project is. In this case, we're going to be connecting to Neural Sunup. And I did not make up that name. Google established it. And I'm going to start showing you how to create data sets and or load data to it. You would come over here, if you're connected to the project, come over here and create your data set. You can call it TC19 demo, default location. We're not really going to get into any query optimization or anything that's outside of the default settings. That's predetermined by Google. So by saying create data set, simply creates it, and then I scroll down, and I see it right. Monica, where?
Okay, TC19 demo is the data set which was just created within our Neural Sunup. So the next thing we'd want to do is load our data. So our options for loading it to the cloud are either retrieving it from the cloud, or if you have it local on your machine, you could then upload the CSV file. In the case of the BLS and the economic data, do you have these local on the machine, Edwin?
So earlier we created them. Let's see if we can find them. Really, you can load any data set. Oh. All right, so this is GDPC1 is data from Fred. I'm going to call that Fred data. And like I said, I'm going to keep all the default settings like they are. I think this is a CSV, and I'm going to load my table.
I think we should use the auto detect for the schema there. There we go, and create our table. And this is now going to populate below TC19 demo in the Google console.
That one actually is an Excel
Or
table.
Is it already loaded somewhere else within the project that we could pull that up?
Yep.
To expedite our process.
So once you load it, right, once that goes naturally, like we expected to, you would see all of that info, like I mentioned earlier, when I loaded my economic quarterly data for that I had prepped for unemployment rate and GDP. You can navigate through it. You can see a preview of what those columns are, the values of each of them. You could also see the details to see more about the number of records, the size of your data, and of course get to see the schema. If you wanted to update the schema, that's something you could do as well. You can start adding descriptions to each individual column. But that is, of course, your ingesting stage of the framework, of the blueprint. But the next step that we want to cover is actually understanding the models that we built and what they entail and what that syntax looks like in the interface, in the BQ interface. So we saved all of those queries ahead of time, and because we were collaborating, we saved them in project queries so we could easily reference them in the interface. So we're going to say Okins. So I saved multiple ones, but the one that we're interested in is this one right here. All right, so
what we're doing here, you can click on the save query and it will populate in the console, so you can choose to run that query again. You can make modifications to that query. So for instance, if you did want to do feature tuning and add in something besides select star, if you wanted to change the number of records in your training model, this is useful to be able to update that query. You can save it, load it into the console, make those modifications, and then run it again.
Yeah, so I found the one query that we're using to actually build or replace the model. So up at the top, you can see how it's saying created in the t-test content under OpenSlaw queue, and it's using the BEA, BLS data that I had already kind of gone through with you guys. I could say TCT test content, and for the purpose of the demo, I'm going to call it TC19. Live demo, and we're going to run it, cross our fingers, hope it works. As that's running, right, if it would have encountered an issue, it would have not started processing the execution of the model creation. So I'm going to confidently say it's going to complete, and I'm going to go to the model that ran earlier, which is in the same data set of that project, TC test content, and that would be within Oken's law. Here's where I could start to see the parameters that I mentioned earlier, right? For evaluation, when you're doing that select star query in your previous command, your previous SQL command to either BQ or Tableau in custom SQL, that's exactly what you're trying to achieve, right? You're trying to generate the results to come from evaluating your model, right? When you go to evaluation, and the next step, of course, is to understand what the query is for predicting. So I'm going to go back to saved queries and find it easily. And I'm again going to open it in the editor. You will have seen how the actual creation of the model has now been completed. You can see Oken's Law TC19 live demo right where I'm highlighting with the mouse icon. Now that I'm ready to, I really just want to experiment. So I'm going to open this query in the editor. I'm going to say, yeah, I'm not concerned with the current query that I'm looking at. And at this point, I can take this exact SQL query, and this is the component that we're going to integrate in Tableau. So we can do Control-A, copy, and that's when we get to Tableau Desktop, right? At that point, we could say, create a new session of Tableau Desktop. We're going to ignore that prompt to connect to previously opened workbooks. We're going to Go to data source. I'm going to look for Google BigQuery. It's a previously connected connection. Once we find it, it's going to ask us to authenticate. I see Monica's account, my account. For the sake of the demo, I'm going to use mine. I'm a little concerned because I think Google has now saved my password in Monica's computer.
Told Ed when I'm going shopping. Saved your credit cards.
And this is the part where you have to, of course, define what project it is that you're interested in connecting to after authenticating. In this case, we're interested in my first project. And we're going to find the data set that we're concerned with. In this case, it's TC test content. And at this point, this is when we transition to our custom SQL connection, right? I know we preach best practices within Tableau ProServe that we want to avoid using custom SQL, but for the sake of integrating BQML in Tableau, we certainly want to use a custom SQL connection. We're going to take that SQL code and ta-da. So now we have generated the same results that we would have seen on the BQ interface, but this, of course, allows us to start to get kind of really flavorful with a bunch of other data elements that we may want to use to enrich the data source. So if I pause for a second and switch back to the workbook that I've created beforehand to integrate it with Fred data and non-predicted data, I'm going to go to that data source, and I'm going to see something that's a little bit more sophisticated. Right? I'm going to be able to see the entire, I'm going to be able to see a query that's a little different from the one that I had used. In this case, I use different partition and different aggregation commands to actually get the percent change of unemployment rate, because I realized the data that I used for testing, for evaluating my prediction, was really the difference instead of the actual percent change. You will also see how I'm making use of a parameter, and I'm getting really flavorful with my SQL. I'm recasting a parameter that's really an integer for year, and I'm casting it as a string, and I'm concatenating that with an actual date type. Okay? And on the right, you get to see how I'm actually creating a join to a table that also exists in BQ, right? So you get to take advantage of cross-database joins and joining with other data that also resides in BQ. And in this case, because I'm running that, the where clause that's saying only take the year specified by my parameter, and I'm using that as an inner join or left join to my other two tables, it actually adjusts the entire kind of timeline of the analysis that I want to look at. So when I come to my prediction, all right, I may want to say, you know what? Although I'm looking at data from 1949 to 2029 because Fred is able to create those projections, you could hopefully see that towards the end, you're getting your predictions actually saying by 2029, quarter four, you'll be about 2.11% change in GDP growth, right? Whereas my Fred data indicates that would be roughly close to 1.81, right? So it starts to kind of get closer to what the prediction is saying. So I thought to myself, well, maybe we don't want to present to our viewers, to our stakeholders, to the consumers of our insights, all of the years that are irrelevant. So in that case, we could create that parameter that's actually a integer type, right? To just say, all right, let's make sure we kind of create the boundaries of the data between 1949 and 2029. And when we start to add it to the SQL, to the custom SQL, we can make the adjustments to transform it into a string so that we can actually filter the data accurately. Because as you'd see, I don't really have, from my BQ table, I should say BQML, I don't actually have year, so I needed to make sure I would kind of convert the year to a date type. And from here, I'm going to go back to my dashboard to show you exactly how quickly that updates. Boom. So this is just one of many ways or many use cases that you could use to update your live visualizations. And from there, I'm going to step away and let Monica introduce logistic regression.
Hi, thanks, Edwin. Okay, so that was an interesting use case and application for linear regression. We stepped through each of those components of our flow diagram. We talked about ingesting the data, our input, creating the model, evaluating. We're going to do those same steps a little bit more quickly. I'm not actually going to work in the console. I'll share my SQL statements with you. But I'm going to talk about, we're going to use logistic regression. So in logistic regression, with a binary, we're looking at a true-false condition, which is our label. So in the case of the data set we're going to look at churn for a telecom customer. So let's say you have a cell phone, and you have these features that are associated with it. When we do a binary logistic regression, when we create that model, we may look at these different features to try and determine what's causing our churn. So we're going to go from that really basic level of descriptive statistics, which we do in Tableau, or predictive, to more prescriptive. So we're moving up the tier, and we're following that same set of steps. We looked at 3 different sets of data and considering what to present. Given our time, we're going to stick with this churn example. But other examples would be a true-false condition with BLS data for predicting above or below a threshold for income, poisonous or edible. If you had a lot of features about a set of mushrooms, let's say, you could predict whether or not a mushroom would be poisonous or edible, or in this case, the renew or churn. Quickly, we can glance at the data set in Desktop. So we see our churn volume is 14%. And another analysis may be aging. So over time, our account tenure, where are we losing accounts, or where are we retaining them? Where are they renewing their subscription? So this is nice. I added a couple of measures just to see what features might be influencing the churn. So for instance, here I looked at international calls, and we found that it was roughly the same percentage churn, roughly that 14%. Then we looked at customer service calls. Well, our churn goes up to 20%. Next, we looked at international plans, and we see the churn goes up to 42%, so more than doubles. If we were going to specify exact features in building our model, having our familiarity with our data set, these may be features that we would want to build in there. So instead of just a select star, these are features we may want to add in there. Here's our flow diagram again, which we're going to see at the bottom of our screen. We are running short on time, so I'll go through this. The content will be available afterwards. But here's our console, which we've seen when Edwin uploaded data. So we've created our data set. And next, I've color-coded things, not being much of a SQL user. I did this just to kind of anchor what each of the pieces are in the Google console. So here we're using this telecom churn data, which I've uploaded from a CSV file. And I've created the input view. So this is existing in our project. And I decided to cast our label the churn, which is a binary 1 or 0, I'm casting it as a string instead of an integer. Because we want to use this, it's not an attribute or feature that we're trying to analyze. Saying select star, so we're going to use all of the features available in our data set, not just international calls, weekend calls, night calls. We're going to look at everything when we build this model. And we could select training data. We don't have time for that in this session. So our next step in that flow again, so we uploaded and ingested, we're then creating our model. This looks quite similar to the linear regression, right? The only difference that we see here is model type is logistic regression. Our input label column is the one that I cast as a string, so it's churn L instead of that binary 1, 0. And this max iterations is actually our learning rate, right? So if you've done gradient descent, or you think about how quickly we're learning or building our model, we can specify here the number of iterations. And the Google console is going to tell us, we'll see our learning rate and the log loss. We'll get some cool metrics in there. So I specified 25 in this case. And I said, let's select everything except for the phone number, because the phone number being an integer, we don't want that to be factored into our model, right? That's a characteristic of our customer base. So I said, select everything except for the phone number. And importantly, here at the end, you see that our training set is going to use randomly 90% of our records. So you could use 10%, 90%. It really depends on the volume of your data and how refined you want your model to be. So when we get to the next step of evaluation, this is where you're going to see the metrics that are telling us how accurate the model is. So there's 2 screenshots here, and they're showing the results using either 10% or 90% to build that training model. The one at the top, we can see the accuracy is about 92%, whereas that was using 10% of the records, whereas using 90% yielded 100% accuracy. We also have the F1 score and log loss. And during our evaluate, we're using that ml.evaluate function. So next, once we say that we like our model, we think that, OK, this is, the accuracy is good. We've gone through our evaluation. We're going to do this predict step. So we're moving pretty quickly through those steps in our flow diagram. In this predict step, we're going to materialize that column of prediction, which is what we want to pull into Tableau. So this is also the SQL that we're going to use in that custom SQL dialog in the desktop interface. So to view the results, we go into Tableau Desktop. We connect to Google BigQuery, authenticate. And here in the dialog, we add in that custom SQL for ml.predict. So next, I created an updated version of the dashboard. So we saw the initial one where we did some exploratory analytics, and we saw what our churn is. We saw how it varied when we added in features. And that was without any model prediction. We noted that there were international calls for maybe causing more churn, or international plan. So here in this case, we have our predicted renew and churn, and we have the aging across the bottom. But in the Tableau Desktop platform, we can use the parameter to then adjust the number of customer service calls and see how that affects our predicted churn. If we like that, we can then do a new iteration and go back into the Google console. And that's where we could say, not just select star, exclude phone. We could say select international calls, customer service. And this really is where we have our insights, right? This becomes our operational or strategic action point, this inflection. Because if we say, hey, it's these customer service calls, is it the wait time on the call? Does it mean we need to staff up operationally? If it's international plans, those customers are the ones that we're losing, then why are they being cannibalized? Strategically, do we need to do something differently from a marketing perspective? So we glean all these insights, and we start to work with our data differently, and we get to use the prediction model. So that was in very abbreviated, rolled it all up for the logistic regression, and we have 130 seconds for questions. Want to add anything else there?
Yeah, so I mean, there are numerous use cases that we probably could have presented. I mean, a few that we had in mind was predicting 3-point outcomes in basketball from NCAA data. We also wanted to show, you know, if you're one who's an energy data analyst, you may have the task at hand to predict the price of natural gas. Well, if you have the imported natural gas figures and the exported natural gas figures, as well as, say, the export rate of liquefied natural gas, these are all like quantitative attributes that you could use to better predict the price of natural gas using a training data set, right? So that's giving you an idea of different data sets you could possibly use. I've been working with clients similar to churn that has a value to the business because it impacts revenue, right? If your members or client base start disconnecting or leaving your operation, leaving your business, that will have an impact on the amount of revenue that you're generating. But there's the other end of the impact that it may have to a business, and that is human capital. Right? How can you retain employees? So you can look at employee data to predict what your staff attrition rates would be. Right? So the possibilities are endless, and you know, we hope you can go home and use the fundamentals that we presented today to start playing and experimenting with data to build better predictions.
That sums it up. Thanks, Edwin.